everyone, we are Asier Echevarria, Miquel Mendive and Alejandro Garcia, and today we're going to talk about the production of Cumene and the optimization of its production process. This is the index we're going to follow. Firstly, we're going to do an introduction to Cumene. What is it and how it is produced and what are the sustainable development goals? Then we will talk about our production process and the different variables involved to obtain a high purity cumene, and at the end we will finish the presentation with a few conclusions. So firstly, what is cumene? Cumene is a petroleum product obtained in petroleum refineries. It is also called isopropylbenzene and it's labeled as an aromatic hydrocarbon. Its formula is the one you can see on the screen, and it can be described as a volatile, clear and colorless liquid at room temperature with a sharp and penetrating odor like petrol. Attending to the security, cumene is an environmental pollutant and its vapors can produce health problems like headache, eye and skin irritation, etc. Also, it is harmful to aquatic life with long-lasting effects. So as we can see, it is a dangerous product not only for humans but also for nature. The main uses of cumene can include the production of other compounds used in the synthesis of phenol and acetone, very used in industry, also as additives of petroleum, and other products like paints, varnishes and detergents. So as we can see, it has a high interest for industry. How it is produced? Cumene is produced by reacting benzene and propylene. The main reaction takes place at high temperature and pressure, and it uses a catalyst in order to increase the velocity of the reaction. But also a secondary reaction takes place, where cumene and propylene react to create p-disopropylbenzene. We have found in our references that the selectivity depends on the temperature where the reaction takes place. So there must be an optimal point for a highest cumene production. The purity of the cumene obtained, it is usually more than 99%, with some petrochemical industry claiming to obtain values a little bit higher than that, as we can see on the screen. Now we are going to talk about the SDG. The SDG mentioned to the Sustainable Development Goals that represent an ambitious plan to enhance peace and prosperity, eradicate poverty and protect the planet. They were introduced by the United Nations in 2015 in order to address the most important challenges. They will be reached in 2030. In our process, we have implemented a few of these SDG like good health and well-being, affordable and clean energy, clean water and sanitation, life below water, and life on land. This is an important point because, as we could see before, cumene is a dangerous pollutant for aquatic life. In our paper, you could find a few more points we have described so deeply. Now we're going to talk about our process. As this one you can see here. It has a reactor where the benzene and propylene react to produce cumene. Here this. After that, cumene passes through a heat exchanger to reduce the fuel. This is the exchanger, sorry. The use of this exchanger corresponds to reduce the fuel consumption. And this cumene finally goes to a distillation process with a few distillation towers, aiming to increase the purity of it. Also, we can see we have here a recirculation of benzene, trying to recycle it and reduce the amount that it is used in this process. The amount of cumene that this process can achieve after calculating with Aspen is 89,300 tons per year. Now, after the implementation in Aspen of our process, now the objective is to maximize the conversion and the efficiency of the process. To achieve this, we have done a sensitivity analysis, and we have seen that the inlet temperature and pressure of the reactor are the parameters that must be studied in order to increase the purity and efficiency. The following figure represents the Cumene purity depending on the inlet temperature, as we can see in the picture. The X represents the temperature and Y-axis represents the purity, and we can see we can achieve at 99% at 345 degrees. If we now attend to the pressure, we can see almost the same. This is purity, the y-axis is purity, the x-axis is pressure, and we can see that here at 25 bar we can achieve a high purity Cumene. Also, we have studied the coolant temperature, and we have determined that at 311 degrees the purity of Cumene increases at the same level as we talked before about this 99%. Another sensibility of the, for example, number of tubes we have studied in the paper, but we couldn't put it here because of time. But please take a look on our paper, because you will find that sensibility analysis. So in conclusion, in this project we have learned a bit more about Cumene production and its incredible value for industry, beginning with how it is produced and what are the applications where it is used. After that, we have talked about the SDGs and the necessity to implement them in our industrial processes, trying to reduce the impact of our chemical process in the environment and people. After that, we have implemented in Aspen our process, and we have made a sensibility analysis identifying the variables that have most influence in the purity of the Cumene obtained. This is the end. Thank you very much for your attention.